Going on, guys? In this video we are going to see how to do line integral of a curve, and in this particular problem we are going to see how to do the line integral for a right half of a circle. But before we go for this problem, let's look at this equation. Here we are going to integrate a curve of function f of x y with respect to ds. This ds represents the equation of our arc length, and if you remember, when we integrate arc length we use this equation. We find the derivative of these variables and square them and add them together and square root, right? That's why we have this formula here. We expanded this one like this, okay? And also we have to, when we do the line integral, we have to parameterize this x y variable with respect to t. Now that's what we are going to do for this question. Here the given function is xy power 4. This is our f of xy. Now we have to parameterize this xy variables with respect to t. Now let's look at this half of the circle equation. And since they have mentioned right half of the circle, that's why we have this half of the circle right here. And in the negative y-axis we are having negative 4, and in the positive y-axis we are having 4, because if you look at the equation, that's x square plus y square is equal to 16. So we know that radius of the circle is going to be 4. That's why we have negative 4 and positive 4. Now to parameterize this one, we know that for a circle we can replace x with cos t. Okay, and since we have the radius is 4, we just put the 4 here. And also y, we can replace y with sin t. Since we have the radius 4, we replace the front with 4. Okay, and to make sure this is correct, we can always rearrange this and bring it back to try to bring it back to this formula. Now here what we can do is we can write this one like x over 4 is equal to cos t, and also we can write this one as y over 4 is equal to sin t. Since we know that trig identity for sin square t plus cos square t is equal to 1, we can square both sides and add them together, and if you do that, this is going to be x square over 16. Here we are going to have y square over 16, and in the other side we are going to have 1, because if we add them together, in the other side we are going to do the same thing. We are going to square these two and we are going to add them together, and sin square plus cos square t is sin square t plus cos square t is equal to 1. So we put 1 right here. Since we have the common denominator, this is going to be just x square plus y square over 16, that's equal to 1, and if we bring this to other side, that's going to be x square plus y square is equal to 16. That's the given equation, right? So this parameterization is correct. Now let's go for this equation. Now we are going to write this parameterized part in this equation, and also we have to know the limits of integration. For this half of the circle, that's starting from here, this is negative 5 by 2 and this end is positive 5 by 2. So the limits of integration is going to be negative 5 by 2 to positive 5 by 2, and the function f of x of t, y of t is going to be, we are going to replace this x and y with parameterization. Okay, for the x value we plug 4 cos t, so this is going to be just 4 cos t here. Then we multiply this one with y power 4, and that's going to be 4 sin t. 4 sin t, and this one is powered by 4, so this is going to be power 4 here. Now we have to plug this equation, so this is going to be just the derivative of this one. If you take the derivative for the cos t, that's going to be negative sin t, so here we are going to have negative 4 sin t, and plus, if we take the derivative for y, in our case y is equal to 4 sin t, so if derivative of y is going to be cos, so this is going to be 4 cos t square. We are going to square both of them, and also we are going to integrate all of them with respect to t. Now let's simplify this one. This going from negative 5 by 2 to 5 by 2. Now this, here we have a 4, and for this one we have 4 power 4. 4 power 4 times 4, that's going to be 4 power 5, and we are left with cos t times sine power 4t, and then in the square root we are going to have this going to be 4 square. Okay, 4 square, and also we can write it as 16, because negative 4 square, that's going to be just 16. It's better to write that way. 16, and here we are going to have sine square t plus, again here we are going to have 16, and that's going to be cos square t, and in the outside we are going to have dt. Now 16, we can take the 16 common, and if we do that, this is going to become, okay, let's rewrite, or just show it here and add them together. From this one we can see we can take 16 together. So if we take 16, this is going to be 16 common, sine square plus cos square t, and if I take this 16 outside, this is going to be just 4. Okay, so here we are going to have 4, and since we have 4 power 5 already, and if you add the multiply this one with this, that's going to become 4 power 6, right? So in this way we are going to have 4 power 6, and from this one you can see inside of square root we have sine square t plus cos square t, and that's a trig identity. We know that sine square t plus cos square t is equal to 1, so we can replace this one with 1. So this is going to be square root of 1, and square root of 1 is going to be just 1, so we can get rid of this square root. Okay, now let's get rid of this one, and we have to remove this 4 because I plugged this 4 with this one. That's how we got 4 power 6. Okay, now we are going to integrate this one respect to t. Now here we can do the Joule substitution since we have the derivative outside, and if we pick Joule as sine t, the dju is going to be derivative of this one, that's going to be cos t dt. Now we can rewrite this equation in terms of Joule. So this is going to be negative 5 by 2 to 5 by 2. And since 4 power 6 is a constant, we can move that one to the front. So this is going to be 4 power 6, and instead of sine power 4t, we can replace it with ju power 4, and cos t dt will be replaced by dju. Okay, now this integration is easy. This is going to be just 4 power 6 times ju power 5 divided by 5, and that's going from negative 5 by 2 to 5 by 2, but when I do the Joule substitution, I should find the new limits of integration. To find that one, what we have to do is we have to plug this negative 5 by 2 instead of this t, and if you do that, sine negative 5 by 2, that's going to be just negative 1, so this is going to be negative 1, and sine positive 5 by 2, that's going to be just 1, so this is going from negative 1 to positive 1, so that's going to be our limits of integration. So here we are going to have negative 1 to positive 1. Now our final answer is going to be 4 power 6 times ju power 5. First I am plugging 1 here, so this is going to be 1 over 5. 1 power 5 is going to be just 1. Okay, so this is going to be 1 over 5. Then minus, since we have odd power, minus 1 times 1 power 5, that's going to be just still minus 1, so this is going to be minus 1 over 5, and if we simplify this one, that's going to give us 4 power 6, 1 over 5 minus minus, that's going to make this one plus, so 1 plus 1, that's going to be 2 over 5. Our final answer is going to be 4 power 6 times 2 over 5, and that's going to be the line integral of this right half of this circle. I hope this helps. Thanks for watching.